All right, let's take a look at your Chapter 8 homework. This is problem number 1. And in this first one, they give you, it says they've got a scrapper elevator company, has 20 sales reps who sell its product through the US and Canada. The number of units sold last month by each representative is listed below. Assume these sales figures to be population values. So I'm going to show you the Excel file in a minute, but some of this is review. They want you to calculate the population mean and also the population standard deviation, which I'm going to call that sigma. So again, let me get to my spreadsheet. I'll show you what I just did on that. And as you can see, you'll note that I went ahead and just listed these vertically. You do your X minus, you add up these numbers. Your total sum of your column is 66. And then of course, just to get the average, you divide by 20. So you take that, divide, 66 over 20, which is your sample, will give you a sample mean of 3.3. And then I went ahead and calculated the standard deviation by taking X minus Xi. So take 2 minus your sample mean, 3 minus your sample mean, just like you've done before. This was a previous chapter concept. And then once you've taken each of these variables minus the mean, square them, add them up, you get 30.2. That's this column. You take 30.2, divide that by 20, and that's going to give you 1.51. That's your variance. And then your standard deviation, which is 1.23. So again, this is a review concept, but this would be your sigma. So let's go back. So as you can see in this problem, that would be your population mean, and then you've got your population standard deviation, and then they took this one out to 2 decimals. So then in this chapter, they do introduce the concept of sample size. And on part D, obviously, if it says if you were able to list all the samples of size 5 from this population of 20, how would they be distributed? And the central limit rule would say that they would be a normal, it would be a normal distribution. Part E says what would be the mean of the sample means? Well, all we know is we got 3.3 as our mu, so that would be our estimate. Now the last one, this one's the new one. They're going to introduce a new concept. They call it the standard error of the mean. And so when they say what's the standard deviation of the sample means, you simply take sigma and divide that by the square root of n. So if our standard deviation was 1.23, divide that by, in this case, our sample size would be 5. So divide that by the square root of 5 of our sample, and that would be 0.55. That's our standard error of the mean. That would be part F. Alrighty, so that is problem 1. Let's check out problem 2. And on all these problems, we're going to be using sample size in our calculations. So we're using the same formula we did chapter 7, except when we go to do our z-value, the new one's going to be z-value equals, it's going to be x bar, because we're going to be looking at sample means, minus mu, and then we're going to divide that all over sigma divided by the square root of n. So we're adding the sample size in our denominator, and instead of just saying x minus x bar, we're going to be saying sample mean. So other than that, we'll use this as our new z-value formula, and then we're still going to be looking in the normal curve. All right, so on the first one, it just says applying the central limit theorem, we do have to have a normal distribution. All right, now the standard error. In this problem, they gave us a standard deviation of 12, so sigma is equal to 12. And notice we've got a, it looks like our sample size, I'm sorry, normal population has a mean of 60. I'm going to go back and read. Sample size in this case is going to be 9. So let me check my mouse. Okay, so on part B, they're going to be asking for us to calculate that. I'm just moving this around. All right, so to get our standard error, we've got 12. Divide that by the square root of 9. So I'm going to write this off to the side here. Boop, boop, boop. So 12 divided by the square root of 9. We know the square root of 9 is 3. So 12 divided by 3, our standard error would be 4. So whenever we go to do our z-value calculation, we would simply see x bar minus mu divided by 4. We would use 4 as our denominator. All right, so that would take care of that one. So then on letter C, we want the probability that the sample mean would be greater than 63. So again, we've got 63 as our sample mean, so we would need to get a z-value. So we would have z-value equals 63 minus 60. Remember, our mu value in the top part was 60, and sigma was what, 12. But of course, we always say sigma x bar now, so we always say sigma is 12 over the square root of 9, or 4. And so we would say 63 minus 60, divide that by 4. And of course, that would be our z-value. And they want it to be greater than. So it's kind of like saying, if we go back and draw our curve, and we had 60 as our mean, that's in the middle, that's our mu value. And then we've got 63. We're essentially looking at the area to the right of that. And so our z-value for C, it looks like it would be about 0.75. Put that right there. All right. So if we got let me draw this out. All right. So if we got 0.75 z-value, so if that z is 0.75, you would go to your z-table, look up 0.75. Remember, your z-table would give you from 0 up to this data point. You would have to take 0.5, 50%, and subtract out that area. And let me get mine pulled up. My area, I'll show you that number in a second. Let me get to my table. So if you looked up, let me share that. There we go. So if you looked up 0.75 in your table, that would give you, it looks like it is 0.2734. So if you got 0.2734, your answer would be 0.5 minus 0.2734, and that should give you your area, which is 0.2266. So that's how you do that one. Of course, that's letter C. All right, let's check out letter D. And this one, we want a sample mean of less than 56. So again, I'll just draw this out for you. So remember 60 is in the middle, and we got 56. And they want the area to the left. So you take 56 minus 60, divide that by 4, because that's our standard error. And then that's going to give us a z-value of, let's check it out, what's the calculation? That'll be, it looks like it's right at a -1. So if our z-value is -1, so then you would go to your table, look up one z-value. Remember, your table would give you the area between 60 and 56, and that would be 0.3413. So if you just take 0.5 minus 0.3413, that would give you your area, which should be to the left. That's 0.1587. All right. And then so once you've got that, then you notice on part E, they want you to look between 56 and between 63. So we've already calculated those two z-values. So you've got, I believe it was for 63, it was a z-value of 0.75. So let me draw you the picture here. So you're essentially looking between, so again, remember zero's in the middle, and you have 0.75z, and you have a -1z. I'm just writing these out as z-values. You're essentially trying to find that area. So there you go. So, all right. So, of course, if you look up 0.75, you're going to get, it looks like it is 0.2734. And if you look up, of course, the 0 to -1 is 0.3413. And all you do is you add those together, and that would give you your area, which is 0.6147. Let me clear that out. And of course, letter E, they're showing you that right down here as well, right there. All right. And then the last one on letter F, it says, what is the probability that the sampling error X minus bar would be 9 or more? That is, what is the probability that the estimate of the population mean is 51, mean is less than 51 or more than 69? So in that case, again, just like before, you've got two Z values you'd have to calculate. So if I draw this out, and remember we've got 60 there, so you got up to 69 or down to 51. Trying to draw this as best I can. So they're wanting you to find that area. And so you can see before you'll have to get your two Z values. And again, let me just show you that calculation down below. You can see the Z value calculations right here again. 51 minus 60, 69 minus 60. You get negative 0.25 and a positive 2.25. And so then you just have to look these tails up. And so the probability of a sampling error. So what they're really wanting you to be is to find the area to the right of each of these, because each of those would take you out more than 9. So if you looked up 2.25, I'm just going to go to my Z table real quick. 2.25 in your table would be 0.4878. So what that's simply telling you is this. Let me show you that. So that means if you get 0.4878 in your table, that's from 60 to 69. So if you take 0.5 minus that, that would give you that tail, which in this case would be 0.0122. And so therefore, using symmetry, this tail is equal to this tail. Each of these tails are both 0.0122. So you just add those together or multiply that by 2, and that's where they're getting the 0.0244. So I hope that makes sense. All right, so that is problem 2. Let's check out problem 3. Let me clear those drawings. So again, applying the central limit rule, again, normal is your answer. The standard error, remember that's just simply your sigma divided by the square root of n. And so in this case, sigma is equal to 5, sample size is 40. So if you just take 5, divide that by the square root of 40, notice they take that out to 2 decimals. So then once you do that, then you're back to essentially doing what we just did on the previous problem. Move this down. So on letter C, it says, what's the probability that a sample mean is less than 74? So they're simply saying, again, let me make sure I got my numbers. The population mean is 75. So all you're doing on these, and I'll illustrate these, I'll show you the calculation. So whenever they say that on C, so you would take your Z value, which is 74, minus the population mean is 75, and then divide that by 0.79. Because remember, this is your sigma over the square root of n. And so in this case, they want less than 74. So if I draw that out, and of course we know that 75 goes in the middle, and then there's 74. They want to the left of 74. I hope that's readable. So once you find that Z value on letter C, let's get the Z value for letter C. It looks like the Z value is negative 1.26. So all you got to do is go to your table, look up positive 1.26, and then of course you'll have to subtract that from 0.5. So if you find that 1.26 area and then subtract that from 0.5, that looks like your answer. I'll just show you the calculation down here. It's 0.3980 in your table, and then 0.5 minus that would give you the rest of the curve. So there's what they're getting, the 0.1038. So again, that's just like the previous problem. All right, that's letter C. And then the rest of these, I'll just kind of highlight. I'll try to at least give you the visual, then you can work them out. But Again, on D, same thing, you draw your curve. 75 is in the middle. Then you've got between 74 and 76. Again, you got to get the Z, so you have, again, 74 minus 75. Divide that by 0.79. And then you have 76 minus 75. Divide that by 0.79. And again, because you're looking between these two, all you got to do is once you get the individual Z values, look up the areas, then you just simply add those together to get the probability. And on letter D, it looks like they're showing you this right down here. Each of these is exactly one, it's a positive and a negative, I guess. 76, and yeah, so it's a plus or minus. So they're getting basically 0.7923. You just have to double the area. All right, so that's letter D. Looks like letter E, you're going between 76 and 77. So on letter, I'm sorry, this is letter E. So again, on this one, we already know 76, 77, the Z value for 77 would be 2.53. And therefore, you should be able to get to that area on letter E. You should get 0.0963. So again, let me again draw you the picture on that one. So just kind of, it might be a good habit every time you do these just to draw the curve. So you got 75, and of course they want 76 to 77. And you're simply trying to find that area. So again, once you get these two Z values, look up the areas, and in this case you would subtract to get that 0.0963. And that would be letter E. So that's what they're essentially doing right there. That's what they're saying. They're subtracting these two to get that area in between. All right. And then we've got letter F, last one. What is the probability that the sampling error would be 1.5 or less? And so in that case, it's very similar to the last problem. Let me just kind of draw you the picture as you're working this, so you can kind of visualize what they actually are asking. Is if you've got 75 in the middle and you go out plus 1.5 and minus 1.5, of course that's going to take you to what, 76.5 and 73.5, and they want, it looks like the question they're asking would be 1.50 or less. So again, you got to find the area in between this time. I think the previous problem they wanted the tails, and this one they want you to find this area. So in this case, you've got the Z value. This one is going to be positive 1.9, and that's a negative 1.9. So if you just look up 1.9, that's going to be 0.4713, and if you just multiply that by 2, that should give you the complete area, which should be the 0.9486. All right, so that's my comment on this one. Hopefully that helps. All right, that's number 3. Let's check out number 4. And on this one, they give us distribution, means 2200, standard deviation is 250, it's normal. It says, what is the probability of selecting a sample of 51 room bedroom apartments and finding the mean to be at least 1950? And so the idea here is if you plug this into your Z-value formula, notice 1950 minus 2200, 250 divided by the square root of n, you get a negative 7.07. Well, you'll note that you cannot find that number in the table. So virtually, essentially, the answer should be 100%. All right, so sometimes I think the largest number on our table is 3.09. Anything outside of that, you're going to be finding it's going to fall off the table. All right, that is number 4. Let's check out number 5. And again, now we're kind of back to doing these same calculations before. I'm not going to do every one of these, but I'll at least give you some hints on these as you're practicing, because these are at this point, just repetition. So standard error, if you read the problem, mu is 5.5. The population standard deviation sigma is 2.2. Our sample size in this problem is going to be selecting a sample of 121. And so we're applying central limit theorem. Standard error is simply sigma over the square root of n. So you'd have 2.2 divided by the square root of 121. And that'll give you about 0.2. It looks like that's what they're looking for. And then the rest of these, you just got to, again, find z values. Remember the z formula you're going to be using is x bar minus mu over that sigma over the square root of n. And since we already know that number, everything, when you do your z value formula, you're going to plug in 0.2 in the denominator. So when you get to part, looks like this has part B. Let me clear the rest of this. So in part B, they want between 5 and 6. And so again, just to kind of give you the visual, remember 5.5 is your middle. And they want between, what, 5 and 6. You're going to have a negative and a positive z value. So you got to get each of these z values, and then of course just look them up, and then you have to add those together. Letter C, they want between 5.3 and 5.7. So again, if that's 5.5, you can map out 5.3 there and 5.7. Get the two z values again, add the two areas together, and then you should come up with this 0.6826. And so again, let me show you the calculations at the bottom, since I just kind of gave you the visuals on B and C. You can see how they're getting the z value, and so therefore they're looking these up, and that's how they're getting the areas. Same for C, you can check that one out as well. And then I think, how strange would it be to obtain a sample mean greater than 6.5? Very unlikely. That would be essentially like an outlier. All right, so that is number 5. Let's check out number 6. Again, standard error of the mean. You know, think of the equation, your sample size is in the denominator. So if you increase the sample size, your standard error would decrease. What happens to the distribution if the sample size is increased? Obviously, it's become more normal. All right, that's number 6. Let's check out number 7. And some of this is going to start to look very repetitive. Again, we're applying the rules of simple central limit theorem. So first one, obviously, you want it to be normal. They want the standard error of the sample mean. Remember, that's your sigma over the square root of n, which in this case gives you 1.1. I like to do when I work these problems is when I first read them, I look at what's the mean. So the mean in this problem is going to be 35. Sigma, I call it sigma, is going to be 5.5. And our sample size is going to be 25. So again, on part B, when you took sigma over the square root of n, you'd have taken 5.5 divided by the square root of 25. So once you come up with this number, then when you do your z, again, just to remind you, when you do your z formulas, it's x bar minus mu divided by 1.1. And then the rest of these are pretty repetitive, pretty much similar to what we did before. They just want you to then find the areas within. So like on the part C, it says more than, what, 36. And so on that one, see, our mean again is 35. So again, using that as our midpoint, all you have to do is just, if it helps you to visualize it, just plug it in, put that 35 there, then you've got 36. Draw your line, they want more, so you're looking to the right. You have to convert that into z value, and then find the area to the right. Looks like letter D, it's 34.5, and again, they want greater than that. So again, just to kind of give you the visual, if that's 35 and you've got 34.5, they would want you to find, again, the area to the right. And then letter E, you're looking between these two numbers, which you just calculated, so you got to find the area within. And then the last one, you got to find, it looks like it's just similar to the previous ones. Page down just to let you see that. It looks like it says the sampling error would be less than or more than 1 hour. So you can plug that in. This is what letter F. You can see the calculations down below from letters A down to letter F. You can see how they're calculating the two Z values on letter F. And then, of course, you can look those areas up. You've got to find the tails on each of those and then double it to get 0.3628. And again, if that doesn't make any sense, let me draw the curve right here again. So they're asking, again, this is for letter F. They're wanting you to find the tails. So if you can find one tail, each of these tails are the same. That's why they always multiply that by 2. All right. I think we've done that concept already. So at this point, you're just repeating some of the previous problems. See number 8. Same thing on 8. Again, normal curve. Get your standard error. In this problem, looks like the mean's 30. Sigma is 2. So again, you take sigma over the square root of n. So sigma being 2, your sample size is 16, 2 over the square root of 16. So again, that's how they're doing that standard error. And then once you get that number, then you're just going to plug that into your denominator for your z-value formula. So for C through F, essentially, again, at this point, you're just repeating them. For C through F, just remember Z is equal to X bar minus mu, and then you're going to be dividing that by 0.5. And then all of these I've already illustrated in the previous ones. I would suggest you draw your curve, map it out, and ask yourself what part of the curve you're looking for. All right, and I'll show you just briefly, real quick, all the calculations. So if you do review this, you can see how they're coming up with the numbers. And if you have any questions, please let me know. Again, this is number 8. You got 2 more I want to comment on. Number 9. On this one, we've got the mean age of men when they marry for the first time is normal. It's 29 years. Standard deviation is 2.5. Sample 60. The likelihood they will be married in less than 29.3 years. So this one's pretty short. And again, I like to draw out what we've got. Mu is 29. Sigma is equal to 2.5. And again, our sample size is 60. So you notice our denominator is sigma over the square root of n. But I'll write out the z formula just to remind you. X bar minus mu over sigma over the square root of n. So in this problem, if I draw out the curve and we put 29 in the middle, and we want 29.3, you convert 29.3 into a z-value, which they're going to show you that right here. Looks like you get 0.93. So if you look at 0.93, in this case, we're married as less than 29.3 years. So remember, what you have to do on this one is the table will give you from 29 to 29.3. So the table will give you 0.3238, but you got to follow through with the rest of the curve to get everything else, which of course we know is 0.5. So you add those two together, and that's how they get to 0.8238. All right, last one, number 10. And then on this one, we've got the mean weight is 6,000 pounds, sigma is 150, it's normal, 40 is our sample size. So let me write these out just so you know as you're working is, just to help you out. So again, mu is 6,000, sigma is given at 150, sample size is 40, again, normal curve, 95% is what we're looking for. So essentially, if 6,000 is in the middle, they want you to get the z-values. You got to find 2 z-values. That's going to give you within up to, 95%. So if I split 95 in half, we know that that's 0.475 and 0.475. If you look that area up in your Z table, that's going to give you 1.96, and that's negative 1.96. And then since we know our Z value, you simply just plug that into your equation and you calculate your margin of error. So if you just take your 1.96Z and multiply that by your standard error of sigma over the square root of n, which in this case is 150 over the square root of 40, that's going to give you your plus and minus. So you got to do plus that and then minus that, and then this will give you the upper limit and the lower limit on that one. Alrighty, so guys, I think that takes care of your chapter, my comments on your chapter 8 homework.